So hi everyone, welcome to my YouTube channel. Myself Sanjeev Reddy. I am from Sri Venkateswara College of Engineering. Today we are going to discuss about lasers. Introduction. Laser is an acronym for light amplification, the stimulated emission of radiation. Lasers are optical phenomenon which find major application in various fields such as medicine, engineering, fiber optic communication, industries, etc. Einstein proposed idea to amplify light and microwaves by utilizing the energy which is released by atoms or molecules during energy level transition. Outline and application of the use of a laser, medical application, communications, barcode scanner, laser disc, surveying, welding and machining metals, drilling tiny holes in metals, production of CDs, reading and writing CDs, DVDs, etc. Characteristics of laser light. The following characteristics distinguish a laser beam from an ordinary light. Highly monochromaticity, highly directionality, coherency, intensity. High monochromaticity. Mono means single and chromo means color. Therefore, monochromacity is a source with single color. It is important to note that energy radiation for all atoms is corresponds to their corresponding energy level, so that frequency of laser light is constant. E is equal to hv. Laser radiates light having single frequency wavelengths known as monochromaticity. This characteristic is very useful in medical treatment because the biological effect is strongly related to wavelength of light and also used as source in many laboratory experiments. High directionality. Laser is almost perfectly parallel. This means that it has good directionality. For the same power, normal light can travel very small distance before it is diverted, but laser could travel very large distance almost without diversion. Delta T is equal to lambda by d. Theta is equal to angle of divergence. Used as ranging device and also used to study planetary distance. High intensity. Due to the coherent nature of laser, it has the ability to focus over a small area of 10 to 6 centimeter by extremely high concentration of it over a small area. Coherence. The wave trains which are identical in phase and directions are called coherent waves. Since all the constituent photons of laser beam possess the same energy, momentum and propagate in same direction, the laser beam is said to be highly coherent. Einstein's theory. In 1916, according to Einstein, the interaction of radiation with matter could be explained in terms of three basic processes: absorption, spontaneous emission, stimulated emission. The three processes are illustrated and discussed in the following. Induced absorption. Let the atom be initially in the lower state, even if a photon of Hv is incident on the atom in the lower state, the atom absorbs the incident photon and gets excited to the higher energy state E2. This process is called induced absorption, as shown in the figure 1. Second one is spontaneous emission. It is a process in which there is an emission of a photon whenever an atom transits from a higher energy state to a lower energy state without the aid of any external agency. For this process to take place, the atom has to be in the excited state. Since the higher energy level is an unusable one, the excited atom in higher energy level E2 spontaneously returns to the lower energy level E1 with the emission of photon of energy Hv is equal to E2 minus E1 as shown in figure. Stimulated emission. Quite by contrast, stimulated emission requires the presence of the radiation when an incident photon of energy Hv is equal to E2 minus E1 passes by an atom in an excited state E2. It stimulates the atom to drop or decay to the lower state E1. In this process, the atom releases a photon of the same energy, directionality, phase, and polarization as that of the photon passing by. The net effect is two identical photons in the place of one, or an increase in the intensity of the incident beam. It is preciously this process of stimulated emission that makes possible the amplification of light in laser. Basic concepts in quasar physics. Population inversion. It is the state of achieving more number of atoms in the excited state compared to the ground state. It can be achieved by process called pumping. Pumping. It is the mechanism of excited atoms from the lower energy state to higher energy state by supplying energy from an external source. The most commonly used pumping mechanism are described below: optical pumping, electrical pumping, direct conversion, lasing. The processes which leads to emission of stimulated photons after establishing the population inversion is referred to as lasing. Lifetime. The limited time for which a particle or an atom remains the excited is known as lifetime. It is about nanosecond. Metastable. It states that energy levels in atomic where lifetime of atoms is very large. Active medium. This is four-level solid-state laser system. Aluminum gallium, commonly known as YAG, topped with radium ions Nd plus 3 is the active medium. Resonator cavity. The end faces of Nd YAG rod are ground polished and silvered to act the optical resonator mirrors. For the optical cavity can be formed by using two reflecting mirrors M1 and M2. Optical pumping. A xenon flash lamp or a krypton flash lamp as a pumping source. Applications. These lasers are used in widely for cutting, drilling, welding, and surface hardening of the industrial products. It is used in long communication. It is used in the study of inertial confident fusion, medical field for ophthalmic surgery and cosmetic surgery, communication and remote sensing field. Thank you.